Okay, so our group, we decided to make a celestial body identifier. We chose to make a celestial body identifier after brainstorming many ideas and deciding on this one. This project stood out as both being possible for us to make and genuinely useful, as it can be actually pretty hard to constantly identify some other planets and other celestial bodies. This is a screenshot of us discussing and liking each other's ideas. We first decided on how many categories we would have, which was originally 13. You can see our finalized categories on the right. We then got the data by using Google Images and downloading all the images on a page using a Chrome extension called Download All Images. We isolated the data by making sure that the pictures actually had celestial bodies in them, as some were blank or bogus. Then we downloaded the clean data and inputted it into Labelbox, a free tool to label bounding boxes around objects in an image, and then output their data into a JSON file. These are just some examples of some pictures that we got off the web. And then we had to sit sorting them out. Yeah, that's it.
The algorithm we were using for image detection is YOLO, which stands for You Only Look Once. We trained it by inputting the outputted images and labeled bounding boxes from Labelbox into it using Python. Not before filtering 80% of the images into training, 10% to testing, and 10% to valid. The algorithm was trained on the 80% and 10%. It was tested afterwards on the remaining 10% that was valid. We used Python to tell us the accuracy and precision of our program in the form of an MAP, which stands for mean average precision score, which was initially 72% and that was brought up to 83% upon the removal of comments. This is graphs of YOLO compared with the other tools that were that also existed. Our key takeaways. One of the lessons we learned was that not all data is clean, and some can be blank or just unusable. We had a category for comments originally. However, since in most of the pictures, they showed comets entering Earth's atmosphere, comets tend to just look like white balls of light, such as this one. Ultimately, we decided to cut out comets, and the program functions better as a whole because of it. Another lesson was in managing difficulties. Whenever we ran into an issue, taking a short break to just think about the problem and then coming back as a group and discussing it tended to work wonderfully. And then we'll be showing off our website.
I think our student is right now in process of it, but guys, the website link is actually in the chat right now. So we definitely can have a check on the website by yourself first, but yeah, let's waiting for our students to share the screen.
All right, can you see my screen?
Yeah, we can see it.
Yep. This is the website for the celestial body identifier. We have a button for where you can try it yourself, a passage on how to use the celestial body identifier, what our mission is, where you can learn more about the solar system, profiles for everybody that worked on this project. We have an about page, which has a timeline and all the steps we took to make our celestial body identifier. And we have some improvements we can make to improve our AI in the future. And then we have a Q&A that could help answer your questions on why it isn't 100% accurate, or how you would use it, or how long it took to teach the AI on how to identify the planets.
Do you mind stopping streaming so I can stream?
Yeah, so
All right. So here's a demonstration of the AI in action. So I'm going to input. I don't think you can see it, but I'm choosing out of my computer just any image. This one is of all the planets in the solar system, and you can see that it labels all of them correctly in order as well, and then shows the confidences down here. And most of them are pretty high confidence. If I had to guess which ones were low confidence, I'd probably say Mars, because it has a tendency to confuse Mars and Venus, since they're usually around the same color. But unfortunately, well, actually, first let me show you an example of what happens when there are no planets in an image. You'll receive, we found no objects, and it'll say no planets, see Y below, which leads me to here where we have an explanation of basically the process, why we sometimes miss, and the confusion matrix of our AI, which shows basically how well it can identify the different planets and celestial bodies, with the scale being like red as the highest and like purple as the lowest. Yeah, so it's not perfect, as I will show you now. Occasionally it messes up, but all in all, I still think that it's a pretty solid AI.